Terminal.
RCP chamber pressure looks good.
Doubling up. Roger, roll, Atlantic.
Water towers, fly!
Tango Delta nominal.
Body down, SC off. Bring in, SC off.
Yikes. You bet. Okay. We don't need any more of these.
Hello, everybody, and welcome to this week's episode of NASA Spaceflight Live, where we are welcoming a very, very special guest to the show to talk about the future of all things Astra in space, Mr. Chris Kemp, Chairman, CEO, and founder of Astra. Chris, thank you so much for joining the show today.
Hey, great to be here. Thanks for having me.
Absolutely. You're also joined by a familiar face and another Chris on the show, Mr. Chris Gebhardt, Assistant Managing Editor at NASASpaceflight. Chris G, thanks for joining us as always.
Cool, likewise, Chris.
And myself, Thomas Burghardt, another reporter here on the NSF team. Thank you all so much for tuning in. We've got a whole bunch of very cool things to talk about with Chris Kemp today. And we'll, of course, be pulling live questions from chat as always. So if you have a question you want to ask Chris, throw them in the chat. And if you tag us with @NASASpaceflight, I'll be pulling those out throughout the show, and we'll be forwarding those and talking about them as well. But I want to get started with just some background on everything Chris Kemp and Astra. So Astra with a couple orbital launch attempts and getting ready for another one here soon. Let's talk about Chris Gebhardt, whose audio is not working, Michael? Okay, so Chris Kemp, I'll start a question for you here. You have a background in information technology. You served as NASA CTO for IT for a bit. How do you go from that to starting your own spaceflight company?
Well, with a great team. My co-founder, Dr. Adam London, did his PhD at MIT on some of the world's smallest rocket engines. And when we met, he built a lot of the core technologies for basically flying rockets. He was actually one of the first folks that had built a team that could land a rocket. And so when we got together, I brought a lot of the business, and I really started to think about how to build the company like a software company, where we take smaller, more iterative steps. And by keeping the rockets small, we could basically take tests and test engines, and in fact test entire rockets at relatively low cost. And so we brought a lot of the principles that I've used building technology companies and software companies into the space industry. And I'm sure we'll talk a lot more about the ways in which we're doing that, including bringing Benjamin Land, who was at Apple for a couple of decades, working on the iPhone, iMac, iPod, things like that, and taking that kind of mentality that you would typically see more in a consumer electronics or a software company, and really bringing a lot of people from that industry into the space industry to just frankly go faster.
Yeah, and we're going to talk a whole lot about that iterative path to orbit because we've seen a lot of iterative steps on the way there. As far as Astra's start, every spaceflight company, and especially every small sat provider, because there are a few of them, has their own market or their own goal, their own take on how to solve the problem of getting access to space. How is Astra pursuing their mission?
Well, I think the thing that really sets Astra apart is scale. So on day one of the things that Adam and I really built the whole business around was the idea of frequent access to space. And the way we expressed that was daily space delivery. So we set out to build a rocket, a launch system, a company, a campus that was capable of producing a rocket a day, and a launch system that was capable of being deployed all over the world, where we could operate from many spaceports, so we could actually operationally achieve this daily launch cadence as well. And so I think if you look at Astra, we're always focused on how do we bring the cost of the rocket down, how do we automate everything so the cost of operations is extremely low. And we set a really bold and ambitious target of having daily space delivery achieved by 2025.
And then as far as achieving that goal, you have set those goals for Astra. What sets that apart from the existing solutions that already exist? What does Astra bring to the table that other companies simply haven't been able to do or haven't tried to do?
Yeah, well, I think that there are some just fantastic companies out there that are building massive rockets that will have the ability to take large amounts of cargo up into space. These are very large rockets, getting larger in a lot of cases, and we think that's a critical piece of infrastructure when you're going to Mars, putting large amounts of things in one place in space. But what we're seeing is hundreds of companies that have all formed over the past 5-10 years. They all have different satellites. They're all very small. They all want to go to different places in space, typically from different places on Earth, all on different schedules. And so it's much like the airline industry. You obviously need cargo planes and big Airbus 380s and 777s. But for every one A380, there's hundreds, if not thousands, of smaller aircraft. For every container ship, there's thousands of trucks that take the cargo off the ship and deliver it where it needs to go. So you can think of Astra as just filling in that gap in the market where we can access anywhere in space on any schedule from anywhere on Earth.
Absolutely. Really quick, Chris G, do we have you back yet? Okay, we'll get a quick.
I can hear him.
I know we could always hear you. We're checking if Stream can hear him. Stream, let us know if Chris G can hear you. Sometimes you are a remote production crew, and all right, we're still working on that. So I'm gonna keep. Don't worry, we got other questions. I'm gonna keep them coming. So let's talk about the iterative path to orbit that we started with.
Yeah.
Astra, I believe we've got a timeline here from your investor deck that we can talk about because there was a whole lot of different steps Astra took to get to where they are now.
Yeah.
Talk us through all of these different milestones that we started with. I mean, began testing back in 2017 and made a couple of launches in 2018 that we might not have heard a whole lot about because those were even before Rocket 3.0. So what were those really early tests like?
Yeah, well, I guess early on we really wanted to focus on really doing all of the hard work required. It's really hard to build a system capable of putting something in space, and in particular putting something in Earth orbit. And so we didn't waste any money on marketing or branding or anything. We didn't have a website. We even chose not to name the company. So we operated as a stealth space company. We called it Rocket, which created a lot of humorous interactions with the military. Cool. General, what's the name of the rocket? Rocket, sir. The rocket has to have a name, Lieutenant. No. Yeah, the picture on the left is actually Adam and I in a garage in 2017. And as you kind of go through the timeline, what you see is Rocket 1.0, Rocket 2.0. We flew both of those rockets. And in fact, we flew the first rocket with a suborbital license just about a year after we started the business. And these iterations were never intended to make it to orbit. In fact, they couldn't make it to orbit. The upper stage of that first rocket was a hunk of metal. And we accepted each of these steps because we would learn a lot about, for example, in that case, the first stage. And with each of these steps, the team got just tremendous amount of data. And you're seeing this same approach now being applied with the Starship program. This isn't how SpaceX did it the first time, but it is definitely the best way to do it. And we applaud how they're iterating and how they're making these generations of spacecraft faster and better. And this is exactly what we're doing. So if you look at the rockets in 2020, we brought one up for the DARPA challenge, almost launched it, blew it up by accident, launched the next one, and the picture on the right is actually our upper stage at 350 kilometers. Could have orbited if we had made a few adjustments to what orbit we targeted, or the fuel mixture. So we've obviously adjusted the fuel mixture, and we'll be doing our first payload delivery this summer, and then we'll be doing monthly launches. In fact, the rockets are already in production to do monthly launches later this year.
So how did you develop that capability? I mean, you're ramping up to monthly launches, which is something that some new space companies took years to get to that point. And relatively speaking, this is a very short-term path from first, test engine firings to an orbital launch capability. How did Astra go about achieving that in such a short time frame?
Well, I think we started out on day one with the objective of daily launches, right? And so most of the team right now isn't even focused on monthly launches; they're focused on weekly launches, right? So we're in the process of expanding our production facility. We're tripling its size to 250,000 square feet, where we're going to have an automated production line. We've been making rockets at about a rate of one per quarter over the past couple of years. We're ramping that to one a month, but all the investment right now is in how do we get one a week and then one a day. and these are the big stages. So in our current facility, which is about a 20-acre campus just outside of San Francisco, we'll be able to produce one rocket a day. And we obviously can't launch one rocket a day from any one spaceport. So we've designed this launch system, which you can see right here, be completely containerized. So we can show up at a concrete pad or a gravel pad with a fence around it, and we bring everything we need to launch the rocket with us. And we demonstrated the ability to do this with the DARPA Launch Challenge last year. And this is how we do every launch. So in fact, if you were to fly a helicopter right now over our campus in Alameda, you would see our entire launch system set up. We're doing cold flow tests today. And that same launcher and the same rocket will actually be packed up, sent up to Kodiak. We'll launch the rocket. We'll actually leave that one up there. And we have another launcher, and that next launcher will go to another launch site where we'll be doing more launches later this year. So it's because of the modularity of the system and the level of automation that we put into this. Only 5 people accompany the entire spaceport in the field, and then we run everything from mission control, and there's only 5 people in mission control. So we've really tried to use a lot of software and automation to bring a lot of the labor and complexity of operating the system as well.
We've got a whole bunch of questions about all that automation because I know that's a huge part of the future of Astra. But I wanted to bring up this photo because you mentioned your testing facility. I believe I'm looking at rocket 1.0 in this photo.
That's right.
So
yeah, very nice.
Early on in the Astra history, but what exactly? I mean, you mentioned they were mostly stage 1 tests because there was not really a stage 2. So what did you learn from these 2 rockets, and how did that prepare you for a first vehicle that was actually orbital capable?
Yeah, there's so much you learn, and it's hard to even characterize it because Astra is a company of teams, and every team is responsible for a piece of that rocket, and in fact that facility as well. And so each of the teams is iterating on the components that they're responsible for. So I look at this picture and I see San Francisco in the background, the Bay Bridge. I see our launch system. That was a hot fire test we conducted out where the Mythbusters operate. In fact, that black asphalt area is where they filmed the movie The Matrix. That was the highway scene, and we built a test site out there. What we look at here is we look at all the changes. The rocket is a different diameter. Between Rocket 1.0 and the Rocket 3 series, we got feedback from the market that we needed to put more payload in space. And with constellations like Kuiper, with the Starlink constellation being deployed, with several other OneWeb and several other constellations, where we really wanted to address that entire market. And so we realized that the rocket needed to be a bit bigger to put these communication satellites up. And so we increased the diameter of the rocket from 38 to 52 inches. We have now, for example, between Rocket 3.3, which flew a few months ago, and Rocket 3.4, we've increased its length by 5 feet because additional efficiencies in the engines mean that we can actually burn more fuel. And so because the diameter was already large enough, we could simply extend its length, and that was all by design. We've got engineers here that are thinking through all these steps. This rocket, which is one of the 3 rockets, you see the nose cone is a different shape. The first rocket we did, 1.0, the nose cone cost almost $250,000 because it was made out of carbon fiber, much like this, the Rocket Lab rockets. We actually want the entire rocket to cost less than that in the end. So you can't make the nose cone cost $250,000 or even anywhere near that and get to the ultimate price target. And so with the Rocket 2 series and 3 series, there were 2 different generations of the nose cones. And if you study the nose cone carefully, you'll see the shape changes a little bit. And the price is now down around $25,000. So we brought an order of magnitude of cost out by using a really innovative aluminum and internal structure made out of aluminum tubes. And that's just one example of hundreds of innovations that you see from rocket to rocket.
We got an up close here of Rocket 3.0, and you can see that very different payload fairing. I remember there was a video Astra put out, kind of a short factory tour when you first revealed yourselves as no longer the stealth space company.
Yeah.
And there was a section about where explicitly avoiding carbon fibers and composites.
Yeah.
We want the simplest materials out there.
Yeah, and 3D printing, by the way.
Yeah, so what's with the deal with avoiding 3D printing? Because that's very popular in a lot of spaceflight companies these days.
Well, it's the most expensive way to make anything, right? If you took a 3D printing machine And a lot of these machines that print metal can cost upwards of $2-3 million. And you put a part like a rocket engine on that machine, it can take days, up to a week, to print a large part. And so you've got a machine that costs millions of dollars tied up for a week printing a single part. You can take that same part and you can stamp it, you can mold it, you can machine it for a fraction of that cost. And so while 3D printing is great for making one of something, if you want to make hundreds or thousands of something, it's incredibly expensive and time consuming. So we've designed this rocket so that we can make almost all the parts without 3D printing them. In fact, we're going to try to move away from 3D printing some of the engine components as well, because it just doesn't scale. You don't see Tesla 3D printing cars. You don't see Apple 3D printing iPhones. It just doesn't make any sense economically if you want to make a business that has any profitability or any ability to scale.
That's interesting. I do have some questions I'm pulling from chat, and as usual, when we have a special guest on, I'm not going to be reading off all of like the super chats and the memberships and stuff like that. So thank you everyone for your support. For now, we're going to focus on some questions, and we've got one here from Cameron who wants to know about the way Astra started and this iterative approach you guys took. And knowing everything that you know now, is there anything that you would go back and organize differently from the beginning, as far as Astra's approach to reaching orbit and bringing that capability up?
Yeah, it's hard. It's hard when things work out to question things, because maybe things wouldn't have worked out if you changed things.
Right.
But the things that I look at are, where could we have not put energy where ultimately things didn't pan. And for us, that translates into really applying a discipline around product management. So what do our customers need? And then what things are engineers working on that directly address those needs in a particular release of what we're building? And if you take a rocket, one of the things that's really challenging about rockets is their complexity. And we use the word combinatorial complexity, which means every single component is pretty closely and tightly coupled to every other component on the rocket. And the challenge with that is, as you scale the company, you have teams that both want to be productive, and productive teams are not impeded by uh, things that impact them. So something that impacts a team is a requirement that changes on them in the middle of development, or something that impacts them, or a skill that they don't have on their team. So we think a lot about at Astra about how we have really hyper productive teams, and it's about taking a system that's very complex and breaking it down into pieces, defining the interfaces so that the teams can really run really hard and fast at a set of requirements. And then when they meet them, that piece of the puzzle gets placed, then the whole thing comes together. And then ultimately, almost everything has to work perfectly on launch day, or you have a failure. And so, the answer is just, if we could have done anything better, it would just be even more invested in building the machine that builds the machine, kind of thinking about how we do Scrum, program management, product management, and just make sure the engineers are never wasting their time on anything, never blocked or impeded by anything, because that's the only way you can really uh, iterate this fast, is having highly productive engineers that are just really brilliant and really focused on what they're doing.
And related to that, you mentioned, all this complexity, which can cause so many different points of failure in especially a spaceflight system. I believe Astra has said you're aiming to build the simplest rocket possible. And how do you go about accomplishing that? I mean, it's not an easy feat or simple feat to get to space.
Yeah, I think Mike Judson, one of our engineers, said that, and that's absolutely right. We have a mantra at Astra: simple scales, which is a simple idea, but the more complicated you make something, the harder it is to manufacture, the harder it is to operate. Typically, the more things that can go wrong with it, the harder it is for people to understand and communicate. And so, a big part of what we're doing is we take everything we do and we seek to simplify it. And that's hard. So, as an example, the rocket we are making today will probably be the most complicated rocket we ever make, because what we're
Hmm.
trying to do is continuously take things away from it. Do we need those baffles in there? Do we need that sensor? Do we need and with every generation, as we understand things more, we're able to simplify.
I believe another prominent rocket CEO has once said the best part is no part, and I think that holds true over at Astra as well. Um, Yeah, so let's build on Rocket 1.0, Rocket 2.0, your first stage test, and then we move into 3.0, which was the DARPA launch challenge. This
Yes.
rocket never actually ended up flying because, of course, like you said, accidentally blew it up. Happens sometimes in rocket development. So, how did that help inform Rocket 3.1 and forward?
Well, we actually learned a lot from that. In in the actual DARPA challenge, we got to T minus 52 seconds. So we were in terminal count, and the whole team's cheering. It's 60, 59, 58. And what actually prevented us from launching, I was very proud of the team because there was a sensor input that we got, and it was probably as one of the tanks was pressurizing, uh, like you ever heard like a tank pressurize and you hear this tink 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 tink
Yep.
things. Well, one of those little noises as the tank was pressurizing was at a frequency that caused one of our accelerometers, which is one of the sensors that measures uh, the position and the velocity of the change of velocity of the rocket, to reset. And it was super interesting because the entire XYZ didn't reset, just one of the axes reset, which was actually an undocumented feature in the sensor that we were using.
Hmm.
And if that had happened in a flight, it could have given our guidance computer data that could have caused really you know very difficult, the consequences of that could be very difficult to predict, right? And you don't want a rocket as it's lifting off to have a guidance computer that doesn't know which direction the thing's pointed, even for a couple of milliseconds. So we decided that the safe thing to do would be to not conduct the launch until we fully root caused that issue. And it turned out to be a really complex issue within a sensor that we had bought, a military grade accelerometer that cost many thousands of dollars. Same thing that you have in your phone, for $5 that Apple and Samsung and LG put in every single phone that probably cost 50 cents. But we got a really expensive one and we expected it to work really well. And frankly, it just, if we'd probably used a cheaper one, it probably would have been better. But that's what happened with that first flight. We learned a lot from that, and then we were able to quickly build another launcher, which reinforced the idea that this portable launch system was a great strategy because we could go back, put it all in containers, rebuild, send it back up there, and launch again 6 months later. And that next flight, we had another really complex issue with guidance, where we had a software, basically the software system had the rocket clocked in a slightly different configuration, and it was going to fly off course, and so we had to turn it off. And so uh, the uh, the safety system just turned the engines off, and the thing fell out of the sky after about 30 seconds. But because we launched, all the data was other than that was perfect. And so we had one line of code in the guidance system that needed to be fixed. But as we scoured all the other data, the engines performed great, the pressurization system performed great, terminal count performed great. And I looked into Adam's eyes and I said, if you guys think everything else was great, why don't we just fix the line of code and fly again? And the engineers, of course, there was a big debate internally. Well, do we put more energy into the upper stage? And we decided, no, we're going to fly again. And frankly, we didn't expect that flight to really reach space, and we didn't expect the upper stage to perform as well as it did because it wasn't tested and qualified to. I mean, we were really just trying to get the first stage working. And when the upper stage lit and the upper stage flew away and the guidance system worked beautifully, uh, and we made it to space, we passed the Von Karman line, we kept going, we kept going, we kept going. We saw the Earth down there. People were crying. Like I've never seen more people see the point in their career and their point in their life where they've achieved something so incredible, that it was absolutely awe-inspiring for me and for Adam and for most of the team. So that Rocket 3 series was a great adventure. Yeah, here's the
Bringing up some photos and some videos. And again, we were talking about before the stream our good friend John Krause, who took most of these. So shout out to Mr. Krause. But about that 3.0 series, so I want to go back to 3.0 really quick.
Yeah.
That DARPA launch challenge was really interesting. The idea where a customer wants to go to you and have you launch, twice in very short succession from completely different parts of the planet, which makes sense with Astra's mission, the transportability and all of that. So how did Astra fit in, and why was that so attractive to a company like Astra?
Well, so we've always believed that in order to really democratize space, there's what 78 space agencies, and I think less than 10 can get to space. So that's most of the world's countries, nation states, space agencies can't get to space. And
Seems
so
like an important criteria for a space agency.
seems like it, yeah. And I think that to some degree, wouldn't it be great if American rockets could be deployed and bring these payloads from these countries into space? And you know, that was something that could only be possible. We're not going to go build spaceports in 50 countries, but if we could take an existing airport or an existing area where we could license a launch and bring the entire launch system, including the spaceport, with us, then we could really open up access from anywhere on Earth, anywhere in space. And one of the projects that we were working on with the DoD, we actually won a contract uh, a couple months ago that I think was announced, where we could actually deliver a payload back to Earth. And so imagine taking a package from a place on Earth and putting it somewhere else on Earth in 45 minutes. And we would do that through a partnership with another company on the kind of reentry side, because we're not working on a reentry vehicle. But it really opens up a lot of possibilities when you have a system like the DARPA Launch Challenge proposed, where you can really set up really quickly. And so we aim to be able to set up in 24 hours.
Sort of Earth-to-Earth transportation. I believe I saw a name Rocket 5.0 attached to that. Is that
Yep.
that would be an adapted vehicle to Rocket 3.0 for that delivery system?
Yeah, I mean, basically, the rockets never stops. I mean, we're continuously iterating on these things, and we have a roadmap that talks about the larger increments. And so, as we move forward, we're expecting to pretty dramatically increase the payload capacity over the next few large generations of the rockets. But our target's 500 kilograms right now, so we'll be able to deliver uh, the major known communication constellations. And the price point again is also very competitive with some of the large rockets at this scale.
Excellent. And I know that's a market that's gotten a lot of attention recently. I know there are other ideas too about that Earth-Earth delivery, especially with passengers. Of course, not necessarily in the mass range of Rocket 3.0. What about some future plans for Astra? I know we're going to talk about this a whole lot, but really
Yeah.
quick, Rocket 5.0. Well, I don't know what happened to Rocket 4.0. I don't know. So, are there other future rockets Astra's got in the works as far as sort of iteratively progressing that way?
Yeah, you'll see Rocket 4.0 next year, and
Oh yeah.
with 4.0, that's a rocket we're targeting weekly launches, and we're targeting several hundred kilograms of payload capacity, and it just takes the next increment forward on a number of different fronts. So we'll have a new engine on the first stage that will be much higher performance, and that engine's already in development, and that's something that we're just always doing across the entire system is looking for both small increments and then large increments. But the target is to have a cost of $500,000 for this 500 kilogram, which is $1,000 a kilogram, which is several times cheaper than the SpaceX rockets are sold for today. So I think that's the North Star, and the North Star of daily space delivery, the North Star of 500 kilograms, the North Star of $500,000 of cost to launch. And so obviously, if we're launching for something for someone tomorrow, just like FedEx, it'll be a little bit more expensive, right? And if we're launching a large mega constellation and we've got an order for hundreds of launches, it'll be a bit less expensive. We're gonna be pricing not based on our cost, but we'll be pricing based on the value to customers.
Excellent. And by the way, I think Chris G, we've got you back now. Chat or Chris G, say hello to everyone in chat. Let us know if you can hear them again. We can't hear Chris G. Maybe Stream can hear him and not us now. We're having some tracking and data relay satellite problems. We'll get him back as soon as we can. I'll keep the questions coming though, and we've got some good ones here from chat. This early launch campaigns occurred from Kodiak, Alaska, which is not a launch site that got a lot of attention recently. There's only been a handful of orbital launches from that site. What made Astra to choose that site, especially with some of the weather conditions that you guys get out there?
That's a great question. It's really the only commercial spaceport in the United States where you can conduct orbital launches. And another trivia fact is Astra was the first company to ever conduct a purely commercial launch from a purely commercial spaceport. We were also the second and third, and I believe the Boca Chica facility down at SpaceX is a commercial spaceport where they're doing some commercial launches, but not orbital launches yet. And so, we're the first company that's been licensed to do a commercial orbital launch from a commercial orbital spaceport. These other spaceports are either government operated, so the ranges at Cape Canaveral, at Vandenberg, are actually managed by the military. And what that means for Astra is we have to comply with both the FAA and also the DoD launch regulations. And that's a lot more overhead for us. And so we ended up in Kodiak because commercial operation where we're purely licensed by the FAA, and it meant one regulatory body that we had to deal with. So it kind of speaks to the goal for Astra is to be as efficient as possible, and having a purely commercial launch is a lot more efficient from a regulatory perspective.
Sure. And let's see, hold on, I'm bringing up some more questions here. Let's see. Some of these questions I'm pulling out, I'm trying to moderate them. So let's move on to other Rocket 3. So let's get to 3.3, I guess. So we've had the 3.0, which was the DARPA launch challenge, and then we had 3.1, which failed during first stage flight, and then 3.2 was the one that finally got to space and just short of orbit. Let's talk about what happened there.
Yeah.
How confident were you guys going into Rocket 3.2's flight? Like you said, you kind of only changed one line of code and went from there. So how confident were you going into that?
We were pretty confident that the first stage would perform, and we had, I would say, medium confidence that the upper stage would ignite, and if it did, we had medium confidence that we would see a full duration burn. So I would say that the goal of that flight was to get through that first stage and to potentially see a successful stage separation event, so that we could set the stage for the upper stage, demonstrating that it would work in the following flight. And we had another flight planned in March. What actually happened, which I think you guys might have a video up here, which is kind of fun, is it all worked. Like, we got to see the entire sequence, including the upper stage signaled back that it had released its payload, and it was a fictitious payload. But here we go. Is this it, or I know?
Yeah, it's coming up. I think we're working server issues to try and get Chris G's audio back, which might be having some issue. But this is video from Rocket 3.2's flight.
Yeah.
Which, by the way, one of the most beautiful launch sites in the world. So from the visual standpoint, we are not complaining at all.
Yeah, and John Kraus, my favorite rocket photographer on Instagram, was up here taking some great pictures for us. So shout out to him. Yeah, so this is the rocket clearing the pad, first stage burn, beautiful. The first stage performed. What happened with both stages was there was some software that capped the amount of mixture adjustments that could occur, and so we ended up with a pretty significant residual of liquid oxygen on both the first stage and the upper stage. And you can see here stage separation, ignition. There we go. And then this is the upper stage going from just under 100 kilometers through the von Karman line and then up to about just over 350 kilometers. We could have targeted a lower altitude and reached orbit, and we could have also targeted a different. I mean, there's lots of ways that this system could have achieved orbit, and certainly it could have achieved the orbit that we had targeted if we didn't have 9% residual liquid oxygen on one on the upper stage. So, in fact, last night I got a note from the team that we've been doing hot fire tests of the upper stage, and I believe we achieved near perfect LOX and kerosene propellant depletion last night on a full duration burn. The team's been working on upgrading both the algorithm that does the mixture, the sensors that sense the fuel levels in both tanks, and a whole bunch of upgrades on all those systems are planned for our next flight, which is later this summer.
Right, and is that pretty much the only change you guys are looking at, solving that fuel mixture ratio? Are there other upgrades that you guys are also looking to implement before the next flight?
Yeah, I mean, there's about 75 smaller little upgrades across the entire system, and we got some more performance out of the upper stage. We got some more performance out of the first stage. The additional performance on the engines has allowed us to stretch the tanks on the first stage by 5 feet. and put a lot more fuel on board. So we've actually increased our payload capacity to about 50 kilograms to a 50-degree inclination orbit, and that's going to allow us to serve all the customers we have for the first flights. We were actually only planning on making about 8 of these rockets, so we've increased the production run of the Rocket 3 series to a dozen, and we'll be flying those monthly starting in the fourth quarter, and then that monthly rate will ramp up to weekly with the Rocket 4 series starting next year.
Interesting. And then, so that next flight, I believe you mentioned will have the first payloads on board. I know might not be able to talk exactly about what they are, but that will be the first time Astra delivers a payload to orbit, assuming that the flight goes well. And later this summer, a lot of people are really excited for that launch attempt. So I'm going to have to ask a question: is there going to be a live stream?
Yes, there will be, and we intend to provide that live stream publicly for the first time. And I'm really excited. I think we've announced that we'll be going public here in the near future on the NASDAQ stock exchange, and our friends at NASDAQ have arranged for us to broadcast the launch live at Times Square on the big screen, and we're really excited about that. We'll be able to bring that experience to a lot of folks in New York and across the world.
That will be super cool, and I think we're all looking forward to that. I know the rest of the team here at NASA Spaceflight, both in Kodiak and perhaps other launch sites, are looking forward to seeing these launches live in person as well, because the more rockets, the better, I think. Bringing in some questions as we finish up talking about this iterative path to get to where you are. A question in chat here: what is the biggest challenges that Astra has faced, or do you think will face in the upcoming future? What's the biggest obstacles you guys are looking at?
Well, as we continue to do this, we intend to continue to push the limits, and as a public company, we're gonna build rockets that aren't going to work, and that's okay. And I think we've seen how quickly you can develop capabilities, as we've watched in awe SpaceX with the Starship program, and I think that's the big change that is happening culturally within the space industry right now. It used to be that rockets were always for people, or they were always going to carry some billion-dollar, exquisite government satellite up to space. Our rockets are really inexpensive, and we look at a machine the size of a Starship, and I don't know how much those cost, but it's absolutely the right thing to do whenever you need to learn as much as you can, as fast as you can, to do as many tests as possible. And so this isn't just true of our launch system. It's true of our customers' satellites as well. Our satellites that we fly are being made by a new generation of companies. They're all startups. They're all trying to learn as fast as they can. The cost of these satellites is relatively low compared to the cost of running the business, just like the cost of our rockets is relatively low compared to the cost of running the business. And so our goal is not 100% reliability. Our goal is to have relatively high reliability at a much lower cost. And just like if a server in a Google data center fails, it doesn't affect your ability to use Gmail. These systems are increasingly distributed. So one satellite in a mega constellation will not stop the service from working. And if we only have one satellite in the launch and we launch 100 times, and if one or two of those don't make it, that's okay. And so I have a lot of empathy for companies like Rocket Lab and some of these new companies, because I think in order to move this industry forward, we're going to have to move fast and accept failure along the way.
It is interesting, and of course, the getting to orbit for the first time, I think, is one of those biggest hurdles. Because once you're there, you know how to do it, and then hopefully the failures should come down. And I know we're all rooting for that. So let's talk about some technical details, because I know we have a lot of technical rocket fans in our audience, and there's a lot of very cool tech on Rocket 3. And let's start with those Delphin engines. And of course, this gives me an excuse to bring up another cool John Krause photo, so I'll do that. But we got some hot fire photos here. So talk about, I believe there are 5 of them on Rocket 3's first stage. Talk about them a little bit.
That's right. Well, these are electric pump-fed engines. Astra designs the battery packs, the speed controller module that takes the power from the batteries, switches them into the electric motors. Astra designs and manufactures the electric motors and the pump assemblies that pump fuel into the combustion chamber. We basically design and manufacture these engines We certainly integrate them here in Alameda. We test them almost every day. There's always work going on to make these things better. I think we've produced just under 50 of these, and 5 of these engines are placed on the first stage. They produce between 6,000 and 7,000 pounds of thrust, and they are 3D printed. The combustion chamber is a 3D printed part, and most of the other parts are machined. So we have, I believe, the impeller and the pump is 3D printed. But so there's 2 3D printed parts that I'm aware of right now in the rocket, and it's the combustion chamber for this thing, and they're by far the most expensive parts on the rocket. So there's
Right.
always the intent is to move to a different manufacturing process for those as quickly as we can.
Are there plans to move towards a different engine, or is this Delphin engine going to be the one that powers your first stages for even across the Rocket 4 or 5 iterations coming up?
No, I think we're planning on some upgrades that will continue to push the engines forward. So this engine is a Rocket 3 thing, and there's going to be some new things coming out with future versions of the rocket.
Interesting. And then Astra's got another engine, which I pronounce Aether. Is that how you pronounce it? The
Ether.
Aether, the upper stage engine, which is a pressure-fed upper stage engine. Can you talk about that a little bit?
Yep. So it's another engine. It produces about up to 1,000 pounds of thrust. In flight, it's typically between 800 and 1,000. We have one of these engines on the upper stage of the vehicle. It is 100% designed, manufactured at Astra. It also has a 3D printed combustion chamber. This picture you're looking at, it does not have its expansion nozzle on it. So it actually, in a flight configuration, would have a much larger nozzle. It's electrically gimbaled, as are the first stage engines. It has, let's see, yeah, it has a. Say anything else? It's a pressure-fed engine, so both the fuel and the LOX tanks are pressurized to supply the propellants to the combustion chamber.
I will assume similarly to your first stage engines, these are also being iteratively upgraded and eventually moved forward to new engines for future rockets as well, right?
Yeah, I think the thing that we're always looking at is how do we globally optimize the entire system, and how many changes do we want to make? If you change everything, that's always the wrong thing to do. If you change nothing, that's always the wrong thing to do. So every team looks at, well, what are we trying to target in terms of the overall system performance? And there's a lot of variables there. So I talk a lot about how Astra is really a software-driven company. A whole bunch of engineers, and we have almost 180 folks now. They need to know what to do. Do we remove this long lead connector from the rocket? Do we reduce the amount of labor that goes into assembling this thing? Do we increase the performance of that thing? There's thousands of things you can do. The question is, what are the right things? And as we look at how to give engineers the information, you have to take everything into consideration, and that's really hard to do with humans. You just spend all your time in meetings talking about things. So what we try to do is collect as much data as we can, and that data can be performance data. That data can be how many hours does it take to assemble things. That data can be how much time do we have to wait for these parts in the supply chain. Bring all that together, and so Astra's built all that software that helps us bring all that data together, so we can share it with the product managers. They can work with the engineers to figure out where is the best time. Where do we best invest time and energy?
Yeah, that's very interesting. And I know automation is a huge part of
Awesome.
the improvements at Astra. You're looking at, again, you have a 5-person launch team, which is unheard of. So, speaking of some automated thing, there is one automated system that's actually a little prevalent, or becoming a little more prevalent in the launch industry.
Yep.
Wondering if Astra is going to use it, the automated flight termination system. I know SpaceX uses it and Rocket Lab uses it. Is Astra looking at that kind of system in the future?
We are flying them, actually. We have an Astra autonomous flight safety system. It is not active in the current flights, but we're in the process of certifying it. So it's
Right.
it's in shadow mode, but it's flying on the Rocket 3 series. And just to give you a sense of how we're thinking about this, the idea is for Astra, mission control will go away. There will
Mm-hmm.
not be a room of screens and people and consoles. We're moving to a model where the concept of mission control goes away. It's all software. It's all software driven.
That's very interesting. And that differs from, of course, the one flight that was terminated, 3.1, which didn't have a traditional flight termination system. You simply stopped producing thrust from the engines and let it kind of fall within the corridor.
That's
What
right.
led to that decision? And is that going to be replaced by the more traditional sort of AFTS that will actively destroy the vehicle?
Mhm. Well, the need to destroy the vehicle is a function of how much damage the vehicle can cause and your ability to actually successfully terminate the engines. And so there's a very rigorous process that we go through with the FAA to make sure that the safety system is able to stop the vehicle within its licensed trajectory. And so we're looking closely at how that evolves as the vehicle evolves, because more or less every time you make any changes, you need to go through the process and certify how that safety system will allow you to always operate safely. I mean, I think the thing that you always have to place first is safety, and then uh, the more you focus on safety, the more you can innovate around that. It doesn't matter if the video feed drops on the launch. That's just annoying. But it really matters that you fly your licensed trajectory, and so we put a lot of our energy into making sure that the safety systems are highly highly tested and highly certified.
Are there benefits to that when operating from, like you said, a commercial spaceport or one that's also not very busy? Do you get a little more room to really set in stone those kind of safety systems?
Well, I would say that the safety systems are the most regulated, most tested, and most certified aspects of the rocket. I mean, if you look at where we invest time in testing, the safety systems, the circuit boards are locked in vacuum chambers and salt air chambers to make sure that if something else fails, okay, that's you lose a rocket, you lose a payload, but if the safety system fails, then you're in an unsafe situation. And so
Hmm.
I think that's something that I think the FAA and the rest of the industry have done a great job of emphasizing.
All right, really quick, and chat, tell me if you can hear him. Chris G, I'm gonna try again. Do we have you? Have you gotten your TDRS antenna working yet?
Awesome.
Oh, I think so. I said a couple test things as you were talking, Chris, and chat seemed to
All
indicate
right,
that
I
they
still
can
can't
hear
hear
me. So
Chris
yes,
G.
I've been.
Chris,
Oh man.
can you
I
hear him?
can. I got him.
Oh,
All
they
right, Chris G
can't.
just doesn't like me, I guess.
Oh, you can.
But
Okay.
I'll keep the questions coming. I'll work on that here. But we mentioned you again removing the launch control almost entirely. Right now, you say you had a team of about 5 people working mission control for a launch. How do you get away with having so few people there? What are they doing? Those 5 positions that you can't get rid of.
Yeah, it's 5 people, and then there's an FAA person that watches in as well. That doesn't work for Astra. There's a mission director. There's a launch conductor. So the launch director, launch conductor. There's someone that's responsible for guidance. There's someone who's responsible for the vehicle control. There's a safety officer, and so there's someone kind of directing all the things. That's the launch conductor. There's the launch director who's kind of overseeing the interaction between the red team out in the field, the range, mission control. Uh, there's someone that's operating the launch system. There's someone that's focused on guidance, and the reason why guidance is a separate position right now, which probably will be combined with the person managing the overall launch system, is the winds and the weather and the kind of uh, in some cases we want to tailor the trajectory to optimize the flight for the wind. And so there's an iterative process where we'll measure the wind conditions, and then we'll in some cases adjust the trajectory in real time to effectively fly the wind that is being presented at the time of the flight.
Gotcha. And a couple of questions for me because I've had to be quiet for 50 minutes and that's unusual for me. But there are a lot of good questions in
Yeah.
chat that we have. And one of them is so you've talked about this idea for daily launches, and I know one of and you can control the manufacturing, you can control the production of the rockets, but the one thing you can't control is if there's a thunderstorm or a
Mhm.
blizzard over the launch complex at launch time. So if the goal is to launch every single day, how weather agnostic or weather durable are you striving to make the rocket vehicles from Astra? Are they more like all rocket vehicles, or will they still have some, oh, wind is too high, or, can they survive a lightning strike? Can they launch in a thunderstorm if the winds
Mhm.
are okay? Where are you sort of aiming for there with the rocket system?
It's a great question. I think when we think of daily launch, we think about not doing it necessarily from one spaceport. So it's an average of one launch per day in that 2025 period, which might mean that you do two launches one day and then no launches the next day or the next day and then two launches, two more launches the following day. It might also mean that we operate from a number of different spaceports, and it will likely mean both of those things. And so Astra is in the process of establishing a number of new spaceports, and we would be able to conduct operations from a spaceport in location A if the weather was bad in location B. And that's how we will achieve that volume is by being diversifying where we're launching and when we're launching.
And sort of along the lines to that diversification, right? Like we see with Rocket Lab, right, that they still need FAA and FCC approval to launch their rockets, even though they're launching from New Zealand. But they're not looking at a launch rate as you are, with like an average of one a day. So how does that interaction work with the FAA and the FCC if you're doing that many launches or planning for that many launches in a given time period?
Yeah, another great question. You look at the FAA and you look at what they do with airlines. There are 100,000 airplanes that take off every day in the United States. And so I think if we can figure out how to take 100,000 airplanes that have people in them and get them from a number, the thousands of airports and get them into airspace, we can figure out a rocket a day, one additional thing that goes through, especially if the rockets are being launched from places like Kodiak, where there's very little air traffic. And I think that this is a very tractable problem. It's as we see companies like Leo Labs, as we see the government itself become more sophisticated in how we understand both what the airspace is doing. And I think Astra was one of the first companies that's been working with the FAA to have the rocket participate uh, with telemetry that airplanes can see. And obviously the rocket at
Oh, wow.
altitude starts to go very fast, and so an airplane couldn't avoid something going tens of thousands of miles an hour, but we're not going tens of thousands of miles an hour until we're well out of the you know commercial airspace.
That's interesting. And
Right, because like there is a point where like you're still over. Oh, sorry, Thomas. I was just saying like
no,
that
go
is
for it.
interesting because there are ports when you look at the ground track and the airspace closure notices, right? The airspace closure notices end at a certain point, but your rocket is still traversing over the ground. So there is like a downrange point, right, where airplanes could be diverted away if there was a problem, a theoretical problem, right, in enough time.
That's right, and I think that the challenge is that rockets travel quickly, and they travel. I mean, really, on their path to orbit, they're traveling around the entire world, and so if the rocket were to fail at a low altitude, it can have a higher probability of impacting something on the ground. The FAA's mission is to protect human life and third-party property. And so, if you look at the statistical, most rockets when they don't work, they tend to not work when they're just kind of leaving. Once a rocket is flying and engines are running and it's well on its way to space, you tend not to have failures. And also in space, these failures tend to result in most of the rocket burning up on reentry once you're at velocity. So these things tend not to be problems. But that's really what this is all about. It's about the statistical uh, analysis of the trajectory and how we can focus on the safety of the stuff below the rocket, which is why we fly right up and over the ocean. And that's why these orbital rockets tend to, if you look at the trajectory of the orbital trajectory from places like Cape Canaveral, Vandenberg, even Boca Chica, they fly up and out over the ocean because not a lot of people or property out there on the ocean to hit.
On the topic of launch sites, we know Kodiak is where you started, and I believe that when they announced the Tropics mission, which NASA will be launching on board Astra rockets, that would actually be launching from another basically surrounded by water site, the Kwajalein Atoll. So is that another launch site Astra is looking to onboard, and what other launch sites might you be looking at?
It is, and we're also in discussions as a backup for that launch with the Cape, and there are a couple of other sites under development that we haven't announced yet, but we'll be announcing soon that are both other government operated and commercial ranges.
How many about are you looking at? I mean, we're talking about daily launches. I mean, we're talking, most operators use less than 5 or so launch sites at most. Most you have like a polar launch site and a low inclination launch site. But if you're launching daily, I mean, is Astra looking at just way more launch sites under their belt and under operations?
Yeah, I think that our objective when we're doing daily space delivery is at around a dozen spaceports we'll be operating from, and that gives us a lot of diversity operationally, where we can accommodate different constraints around the spaceports. And if you look at the number of launches happening out of the Cape, for example, now with SpaceX, if we have somewhere between 6 and 12 spaceports we're operating from, this won't be a significant increase uh, in what you're otherwise seeing out of the Cape.
So sort of along the lines of flight rate and where and where you're flying from, how many spaceports do you think you need? This is a question from our chat. How many spaceports are you sort of aiming for to achieve that daily rate?
Well, again, we're looking at about a dozen spaceports, and so we're looking at hundreds of potential locations, both in the United States and abroad. And there's a lot of constraints. You want to go where people want you. You want to go where it's safe to operate. You want to go where logistics and infrastructure allows you to operate. And there's a lot of factors there as we look at these different sites.
Okay, and then when do you think you'll actually start using those? Because right now you've got the next launch, which I believe will still be from Kodiak, the Rocket 3.3. When do you see, are you going to stick with Kodiak for a while since you've been operating there for a few operational missions
Yeah,
for a while, or are we going to see you popping up at a new spaceport pretty soon?
yeah, we're gonna continue to operate out of Kodiak, Alaska, and the Kodiak Pacific Spaceport Complex. They've been fantastic partners for Astra. We continue to we'll have a long-term relationship. We'll continue to fly for many years to come. We do intend to do some flights that we've announced with NASA, with the new NASA Tropics missions, the NASA BCLS missions. Some of those missions require us to fly closer to the equator, so that's why we're looking at the Cape and Kwaj, and those are this winter. So these flights will be in the fairly near future, and so we're kind of very actively working with both the Cape and Kwaj on those sites.
Sort of along the lines of land launch sites, are there any plans for sea-based launch sites if you needed to get like right on the equator or something like that? And what about security when you're transporting these launch systems to
Mhm.
different countries and across the world?
Yeah, I think the thing that we've been looking very closely at is an ocean-based launch platform. Astra does have on its campus a 500-foot pier on the San Francisco Bay where we can place assets that are focused on the kind of maritime operations. We are we're excited about that because you're very far away from people and property when you're out on the open ocean. And um, in terms of the system, given that it's all completely managed remotely, we have a lot of opportunities from a security perspective to basically make the system completely inert. And I think that's super helpful. And we're going to obviously continue to work with the government to find new ways to disable the system should it fall out of Astra hands.
And as far as, I guess that would almost count as one, but it's also as far as land-based sites. Have you thought about implementing a private launch site, one owned and operated by Astra, similar to how SpaceX operates their Boca Chica site, rather than external, range tracking assets and things like that?
Yeah, absolutely. And I think that Astra operates almost all the infrastructure on that site. So we have our own radio telemetry dishes. With autonomous flight termination, we'll be able to conduct a launch with only Astra assets. So we don't actually need any range assets after we get the autonomous flight safety system certified with the FAA. And private land, we're private spaceports. If you own a big chunk of land on the ocean, let us know. Yeah.
I don't know, me and Chris up here in Daytona, but maybe you can use the beach. I don't know. We get a front row seat.
We're excited. We're talking to Florida, and we're really
I know,
excited.
right?
Texas and Florida are top on our list of states, and I think even Michigan's expressed some interest in partnering with us. Yeah.
Yeah, those were all the questions we had in chat about launch sites, Thomas.
Okay, I want to bring on some other future plan questions then. A lot of big talk in the aerospace industry these days is about reusability, which has been mostly focused around, like you said, the big rockets that we've seen from SpaceX and companies like that. Not sure how well that's going to scale to smaller rockets, although some of the small sat launch providers are now looking at that as well. Is that something that Astra could be considering in the future terms for their rockets?
I think that we look at this in purely financial terms. So when you reuse a small rocket, you have to either carry a lot of extra propellant on board to turn it around and land it, or you have to carry a parachute. And all of this allows you to then have to recover the system, refurbish the system, also that you can make fewer of them. And if you think about the uh, the cost of making what is fundamentally a big aluminum can, and I don't have one on my desk here, but I think 100 billion aluminum cans are made every day or something like that. It's a truly absurd number. Aluminum is one of the most common materials on Earth. It's recyclable. It's recycled. Uh, our objective will be to make the rockets out of recycled aluminum. Make them so that they almost entirely vaporize upon reentry, so that we can use every bit of fuel and simplify the structure as much as possible. So if the rocket is almost entirely aluminum and it almost entirely vaporizes upon reentry, and we can make them for a few $100,000, the cost of recovering them is probably more than that. And so at least right now, as we look at the problem, the way to optimize the economics of a high volume, low cost system like the one we're building is to not attempt to reuse the system. So we would disagree with that. And we would disagree based on a lot of data and science and not marketing. I mean, we're going to do the right thing for our investors and our customers. And the right thing is always pretty obvious as you study the data. And trying to reuse a small rocket does not make sense from a science perspective. Assuming you can make it very inexpensively. And I think that's the thing. If it costs millions of dollars to make the rocket, you totally want to reuse it. And so I can see why companies like Rocket Lab, when they have a Ferrari carbon fiber expensive thing, totally don't want to throw that away. So I see where they're going down that path. But for Astra, when our target is to make the entire rocket for a couple $100,000, it just doesn't make any sense for us.
So, not necessarily along the lines of reusability, but you mentioned the components of the rocket that would burn up completely in the atmosphere, and we do have a question from one of our listeners about what Astra's philosophy on space junk is, and how will you manage that second stage that does go orbital?
Yeah, we have a position that you should make sure that anything that goes into space comes back down. So our strategy is actually to not just end with the launch system, but we talked a lot about our platform involving space services. So the smarts of the rocket will actually be the spacecraft or one of the spacecraft that we're deploying in space for our customers. And so that's the avionics, the PC boards, the flight computer will be the same flight computer in the spacecraft. And so the thing that's being discarded will truly be just some aluminum that will vaporize and or dissolve in salt water within a few weeks. And that's our target. So what we leave in space then will be able to propulsively deorbit. And when it does that, it will burn up. And so, the thinking is, you look at an iPhone, for example. These devices were intended to have about a 3-year lifespan. And what's beautiful about low Earth orbit is if you're in low Earth orbit, you can target a particular orbital lifespan. So, and it could be 3 years or 4 years. And uh, if you're flying in these lower orbits, the Earth has its own garbage collector. It's called gravity. And at about the same time that Moore's law makes the technology in this phone obsolete, uh, it's going to deorbit, and it gets recycled back into the Earth's environment. And I think that's a beautiful thing. And so I think that's one of the reasons why we like low Earth orbit, because we're kind of impedance matching Moore's law with the orbital lifetime. And it turns out that if you double the distance between a transmitter and a receiver, it's 4 times as much power to get the same amount of information across, and it's also twice as much latency. And so if you're building a communication satellite, you actually want it to be in a lower orbit. If you're taking a picture of something, you actually want to be closer to your subject, or your lens has to be much larger. So, in from almost every perspective, from a physics perspective, you want to be lower. And this also happens to be very friendly to the environment, because you're simply recycling the technology as it becomes obsolete.
Okay, Chris, I want to talk a little bit about Astra and how they are positioning themselves among some other rocket companies and other offerings that are similar or drastically different. First and foremost, the small sat launch market. There's been a lot of different takes on how many different providers can be supported in that market. Some people say that there's only going to be 1 or 2 companies that can fill that, where others say there's room for 10 companies. What is your take on what that market looks like and how many different small sat launch vehicles can be operational and have a customer base?
Yeah, I think that there is a big difference between the large rockets that SpaceX is building, and now Rocket Lab wants to build, and this market where you have frequent access from anywhere on Earth to anywhere in space. The focus is on uh, the volume and the scale and the access, right? So access to space is something that's very important to Astra. I think that the moment you start to make bigger rockets, especially if you put people on rockets, especially if you start reusing rockets, that is a path that goes right to SpaceX's door, and I think they're doing a great job. And we're trying to let them do that because it's super inspiring to all of us at Astra, and they've got that well covered. So we're going to the extreme other end of the spectrum and saying, well, how do we go and operate a system globally from as many spaceports as possible? How do we manufacture someday thousands of rockets a year, and truly democratize access to space? And so, who's competing with us on that front? It's not clear. We have Virgin Orbit with a vehicle that they sell for $12 million. That's 3 times more expensive. It's carbon fiber. You need to deploy a 747 every time you fly it, with 12 shipping containers behind it. Uh, that's our competitor. That's our only direct competitor that has access to space that's demonstrated performance and orbital access. And then Rocket Lab obviously is kind of pivoting to do the larger neutron vehicle. So for as much talk about there being all these companies out there, Astra really does stand apart as the only company really committed to scale and ubiquitous access to space.
And I think that shows with one of the more recent customers that Astra has announced, which is this Tropics mission for NASA. 3 different launches that will be going on Astra launch vehicles. And interestingly, when the selection document for that contract came out, there was some interesting competitors in that document, not just the ones that people might traditionally put in the small sat market, like you said, Rocket Lab and Virgin Orbit were in there, which Astra beat. Astra also beat a really, really big rocket from down in Boca Chica that SpaceX is offering. So there is, some perspective for, rideshare missions and small satellites on really big vehicles. What does Astra do that says, you know what, you want to fly with Astra instead?
Yeah, I think that we were really surprised and quite intrigued and humbled by SpaceX competing with us, and of course beating SpaceX on that. It'll be very interesting to see just how much it does cost to fly a Starship
Right.
someday. And Elon's said how much his objective is. It's still a lot of fuel. It's
Mhm.
still a very large machine. And one has to imagine that the logistics and the overhead and the insurance and there will be a fixed cost associated with that. Just like there's a fixed cost associated with an Airbus 380 or a 777, the fuel does cost something. It doesn't cost nothing. So I think if we can really just focus on making the metal that wraps around our fuel cost as little as possible and just drive scale and production rates higher, we're going to have a very competitive alternative to flying a vehicle of that size. We're never going to go to Mars. We're never going to put people on our system. But for delivering payloads exactly where they need to go on the exact schedule they need to get there, I think we can't be beat. But you have to just completely focus on that and not be distracted with making bigger rockets or putting people on rockets or reusability. Uh, what really we're obsessed with is scale, and we're obsessed with what our customers need us to do. And our customers tell us we have over 50 launches under contract. There's billions of dollars of opportunities out there for us to fly additional payloads, small companies, big companies, mega constellations. If we focus on that, Astra will definitely be one of those companies that, whether there's another competitor that's competing with us in that space or not, I don't know. We'll see.
And then this other contract, which is a little more common in the small sat area, you have a new partnership with Planet Labs for a multi-launch mission that will be launching on Astra rockets. That's something that people would more traditionally put in the small sat launch market. However, they're launching dozens and dozens of satellites, which is also the kind of market that you see on a rideshare vehicle and SpaceX's new like transporter offerings and things like that. So how does Astra set themselves apart from those kind of rideshare offerings?
Well, again, this contract was awarded to Astra because we created something that they couldn't get from SpaceX, right? We were able to provide launches on a schedule and exactly where they wanted to go, exactly when they wanted to get there. So I think the thing that is unique about Astra is because we're not ride sharing with a primary payload. There isn't some other large customer dictating where you're going. And if you think about even with a Sherpa vehicle, even with companies like Momentus that say, well, we'll take you from where SpaceX drops you off, and we'll take months to get you where you want to go. Well, months is a lot of money. Like waiting 3 or 6 months to get to the orbit where you want to go costs that company all that time. And if you're a startup, that could cost tens or hundreds of thousands or millions of dollars a month just waiting until you can start generating revenue from that service as it's waiting to get repositioned in orbit. So I think if we can argue that by getting exactly where you want to go, exactly when you want to get there, when I ship a package, I don't think should I use FedEx or Maersk, you know? Sure, Maersk is going to get my package there for 0.000001 cents, a kilogram, but I FedEx it because I want it there tomorrow. And I think a lot of companies, the value of time is high, and a lot of folks value being able to immediately just go to the airport, get on a plane, go where you want to go. And I think that changes the market in a really fundamental way. When space is this accessible, then everybody just develops things and assumes they can get things out there. When Amazon Web Services came out, the difference between starting a tech company 20 years ago and today is 20 years ago, we had to build data centers. We had to build networks. We had to do peering. We had to, it would take often years to do what you can literally do in seconds with AWS. And so Astra's vision for a platform is our customers shouldn't even have to build satellites. They should just plug and play sensors or deploy software on an existing constellation. And that makes space truly accessible, right? Because then, just like you build a website on the cloud, you can build space services on Astra. And I think that really starts to accelerate things even more, which is really what I'm passionate about doing, is just really taking space to the next level, making it a platform.
And sort of along those lines, to platforms, we have a couple questions here from our audience. One is that this all sounds great, and we've kind of heard this before from Rocket Lab and from SpaceX, that if you make the system cheap enough, they will come. But both SpaceX and Rocket Lab are kind of finding out that that wasn't panning out the way they wanted. So is what you just said about a plug and play option, sort of how Astra envisions not only enabling an everyday market, but having the everyday market sort of build around this concept.
Yeah, I think that the more, if you look at companies that were pioneers in this industry, like Planet, for example, one of our customers today, they had to build everything from scratch. I think Planet talks about how they've built dozens of generations of their Dove satellite. Well, every single time, just like we built all these rockets, every time you have to figure out how to make star trackers work, every time reaction wheels and solar panels and power management systems and satellite buses, and it's like when the computer industry required you to build your own computer. It's like the homebrew computer club in the 1970s here in Silicon Valley, where you had Steve Wozniak soldering chips to boards and everything was custom. And to have a personal computer, you had to build it yourself. When I grew up, Apple had come out and Dell had come out, but when I was growing up building my early companies, we had to go build data centers, and it was the same thing. Now, no one has to understand any of this stuff. You can focus on your customers. You can focus on the value that you're trying to create. You don't have to go build a data center to build an app on your phone. The phone's already built. The cloud's already built. You focus on what's unique to you. And I think that's where space is headed. And the Astra platform and the spacecraft that we're building, that we'll be launching with our rockets, it won't be like Starlink, like it's Comcast. It'll be like AWS, where our customers will be able to directly plug and play sensors into the satellites, cameras, radios, whatever, hyperspectral imagers. They'll be able to bring the innovation on board, and like Intel allowed a PC to be anything to anyone because plug and play USB. We'll be able to plug just the thing that the company wants. Then they'll load their software on it, and they're up and running in months instead of years. And I think that's where we'll dramatically accelerate the market, and we'll start to see new applications and new businesses and new killer apps all being delivered from space. Like I want to see, what is the next GPS? What is the next, what is the next thing that will really change everything here on Earth from space?
And as far as that building that space systems platform, you have mentioned Astra is looking at featuring their own satellite bus. What will that look like, and how will that compare with another offering from Rocket Lab and their Photon satellite bus?
Well, it won't just be one, one bus, right? It'll be many of these things, like Starlink, except it won't be proprietary. It'll be like a cloud constellation. So the idea is that we'll use our frequent access to space to populate lots of satellites and lots of planes, and then allow our customers to, at the last minute, plug and play sensors and things into these satellites, and then also deploy software on them. And so this spacecraft platform will be truly revolutionary because it's the first time we'll make it easy to, within seconds, deploy apps in space. And just like loading an app on your iPhone, it's going to allow the platform to be the focus. And this is where we brought in folks like Benjamin Lyon from Apple. He built a lot of the core technologies with Steve Jobs with the iPhone. And when you think about a phone, it's a satellite. I mean, it's got a very low power CPU, memory. It's very lightweight. It's small, fits in your pocket, has batteries, has sensors. And you take the screen off and you put a solar panel on it. It's a great satellite.
That's interesting. And will this Astra satellite system, is that going to be limited to Astra launch services, or could that go elsewhere for launches as well?
Yeah, I think the thing that we're doing is vertically integrating everything. So just like our engines aren't sold separately, the whole system is designed as a system. So it's kind of like the Apple ecosystem, right? So it makes it easier for us to design everything together, because every time there's a new spacecraft, the rocket might evolve to support the spacecraft. And certainly the launcher evolves to support the rocket, and the spaceport evolves to support the launcher. And so there's services on the very top of this stack that drive all the innovation down into all the different products and components in the stack. So we view it very much like a tech stack, and we view ultimately the value that we create in space, a healthier, more connected planet, as the outcome that we and our customers try to achieve from space. And so it's about how do we accelerate the time to value, and how do we get our customers up in space faster, doing things faster, sensing things, connecting things, communicating. How do we get stuff in space faster? And having every company have to build their own custom satellites is like building your own custom computer every time you want to do something on a computer. It just let's remove all the barriers and let's make it easier for people to build. And that's what it'll create. That's what creates a new marketplace. This $1 trillion space economy. We have to get there faster, and we get there faster by making it easier for customers.
So sort of along the lines of what you were saying about apps in space, and a lot of our communication is rightfully directed down toward the planet, since that's where all but 7 of us live at any one given time. But if the future that's sort of envisioned here comes to fruition in even a small way, we're talking about human outposts in low Earth orbit, not just the International Space Station. We're talking about outposts on the moon and things like that. So this sort of connectivity constellation that you're talking about for Astra, is that also able to be either directed outward or upward from low Earth orbit to where these other stations might be, or are these ideas scalable, like you've been talking about, to lunar orbit, things like that?
I think the ideas are scalable, but our focus really is on the Earth. And we say our mission is to improve life on Earth from space. We talk about a vision of a healthier, more connected planet. This focuses Astra, just like we focused the team on a rocket capable of reaching orbit that fits in a shipping container, and then make it better, make it better, make it better, but try to always keep it in a form factor where it can be easily positioned and deployed. Constraints are good, and I think one of the mistakes that a lot of companies, one of the traps you fall into is you try to be everything to everyone, and we're not. We're really focused on the Earth, and some other really smart people are focused on Mars, so we're not worried about Mars. And by being really focused on the Earth, it keeps us in low Earth orbit. It keeps us not focused on putting people on rockets, which allows us to really globally optimize around a set of more tractable engineering constraints.
I want to ask about another product that Astra is working on that I don't think any of us know much at all about, but say for a couple job listings that have shown up on the Astra site, talking about something called Astra OS. I know we got a bunch of people asking, what the heck is Astra OS? Can you talk about that a little bit?
I sure can, and we're probably going to be opening up about 50 new job openings in this area in the next month or two. We're announcing a pretty exciting leader for this probably in the next week or two. If you think about the company, it fundamentally it has to be efficient, just like a rocket. You don't have any extra mass for structures because if it's not fuel, then and it's not payload, then it's rocket, and rocket is overhead. And so you don't want any overhead in the rocket. You don't want any overhead in the company. The way you don't have overhead in the company is you have systems and software that helps people make good decisions. And Astra OS is our financial systems. It's the systems that help engineers do their product development. It's our program management systems. It's all the core software that runs the business. So it's the operating system of Astra. And we've built it on the foundation of an accounting system. And so every time we have a part on the rocket, we understand what it costs. We understand how much labor goes into putting it together. We understand what the lead time on it was for the raw material. We understand how many hours it spent on a machine. We understand what that machine cost. We understand what the depreciation of that machine is and how that contributes to the. So as a public company, we have to be extremely good at this stuff, right? Because our shareholders will expect ever increasing cash flow and profitability. And to do that well, our engineers need to focus on the right things. And so Astra OS is that underlying software fabric that brings data. It makes data accessible to folks that are making decisions. It helps us make the right decisions. And it powers like every bit of data from every sensor ever recorded on any test in the entire history of Astra is accessible to every engineer in real time. And it's all in the cloud, in AWS GovCloud. And AWS is a fantastic partner to Astra. So what we're doing is we're making, and all that data is what streams onto people's screens during launches. And it's what powers every test, it's what powers every launch, and it's all based on a proprietary Astra platform, and that's Astra OS. So if you're interested in software and rockets, go to astra.com/careers. It's a lot of opportunities.
and sort of exactly. And sort of exactly along those lines, Vincente in our chat was wondering, when you seem to have a very lean, mean team. So when you are looking for people to join your team, what are you looking for? What are you considering when you're looking for someone? Specifically, this question is aimed at graduate students.
Yeah.
But in general, like who are you looking for on the Astra team?
Well, so every team, and the way we're organized is we have folks in different departments. So we have a propulsion department. A guy named Mike Green leads it. He did a lot of work at Blue Origin on B2, 3, 4, 5. We have within that department people that have specialties, and then those people are placed on teams that are responsible for developing products. And so the Ether engine we talked about, the Delphin engine we talked about, new engines we're working on. Those are teams, and those teams are atomic focused teams where we give them money and resources. Every team we're trying to build out with the right people. And if you're working on a turbopump, that's different than if you're working on an electric motor, which is different than if you're working on a pressure-fed engine, which is different than you're working on the tank structures for an upper stage. And so what we do is we really look carefully at what we need on each of these teams, and then that the manager of the department works with the leader of the team, and we really try to put a position description together that reflects that. And then there's a very rigorous interview process. So you're meeting members of your team, you're meeting members of the department. I personally interview every single candidate before we put a job offer out, and that just gives me a sense of culture and values, and I make time for that every day. And so it really is all about building. We have an incredible team. Like if you look at, it's not just the talent that you see on the website and the people you hear about. It's like it goes down to every technician, and we really pride ourselves on creating a place where they can be really productive, and we're really supporting them in the work that they're doing. And it really is the key to everything. You can either have a team working 11 hours a day, 6 days a week, that you're driving hard, or you can have a really smart team, really focused, always working on the right things, and they can work 5 days a week, 10 hours a day versus 6 days. So I think it is all about treating people well, and just really bringing the right people together that share values, diversity, respect, inclusion, the simple scales mentality, the ability to take risks, and we screen for a lot of stuff to bring the team together. Work really hard on it.
That is very interesting to hear and sounds super exciting. I do want to kind of wrap this up. We are running out of time, and we've got a whole queue of other questions, I know.
Keep going.
So we tried to get to the best that we could, but I do want one big question, because the whole thing is about the future of Astra, and we're all looking forward to the next flight, and then everything that's going to build on for that into future versions of Astra's rockets, and everything that could open up. So where do you see Astra as a company in 5 years, 10 years, maybe even 100 years down the line?
Great question. Maybe I'll start with 100 years because it's a little easier. It's a little easier than 5 to 10. It's always tough, right in between. But if you look 50 years ago, for example, one of my favorite photographs, and I've used it when I was at NASA, when I was a CTO of NASA, I used it in a lot of presentations because it was really inspiring to me, was a photograph that was taken on the way to the moon. And I believe astronaut Bill Anders took it from the Apollo 8 spacecraft Christmas Eve as he was flying to the moon. NASA, for astronauts, they have these checklists. They say, do this, do this, do this, do this. This was not on the checklist. Looking back in the lunar vehicle and taking a picture back at Earth. But that picture became, that's it, I believe. And that's actually not it, because that's when they were on the moon. But there was a picture on the way to the moon that looks very similar to that. And it's probably the most reproduced picture in history because it started the whole Earth movement. And it was the first time anyone had ever captured a picture of the Earth from space, like the entire Earth from space. And I think about what that might look like 50 years or 100 years from now. And it doesn't look like Wall-E, where there's a cloud of crap around the Earth. But I think it could, just like the atmosphere is this beautiful blue, thin blue line where everyone who's ever lived has lived, and every civilization has risen and fallen. But it could be like a bubble of intelligence where we can measure the temperature of the oceans and the water level and understand the weather very precisely. It could potentially absorb energy as the sun's hitting the energy from one side of the and beam it back around and down to the dark side of the planet. Totally solve the energy crisis. You could reflect the energy before it ever even gets absorbed by our atmosphere. Make the climate whatever you want it to be. You could actually be with near perfect understanding of weather because you have these sensors that can understand air temperatures, wind speeds, ocean temperatures, and quantum computers and AI being able to predict very accurate weather. You could open these little things up like louvers, and you could heat the ocean, causing it to rain in areas where there's drought. Eliminating famine and allowing crops to grow in areas and deserts. You could really make the planet smart, right? You could help manage the precious finite resources we have in a much more intelligent way. And I think that's 100 years from now. So what does that bubble, what does that sphere of silicon and intelligence look like? Well, is it a proprietary platform controlled by some Rockefeller of the year 2200? I hope not. I hope it's a platform like the internet. And I hope, there'll be companies like Amazon that power a lot of that, but there'll be competition as well. There'll be Microsoft and there'll be Google and there'll be Apple and there'll be great companies globally. And so I see that space as a platform for innovation, for competition, and for humanity to build something that helps us really create a healthier, more connected planet and really does improve life on Earth. And we're just getting started. And Astra is starting to build that first, the first building blocks of that platform starting this year.
That all sounds super exciting, and that's such a mission that I think all of us can get behind, making, Earth better via space flight. I mean, every time we see a launch from space, we always get asked, what is this doing? Why are we doing this? What's the purpose? And I think all of those things that you're talking about, and all the different problems that we can work on with just low Earth orbit space flight is all super, super exciting. Chris Kemp, thank you so much for joining us for the show. It has been an absolute pleasure talking to you today about everything Astro, and we are so looking forward to more launches, especially live streamed ones, because us rocket fans like to see them live. And I know we're looking forward to that and everything else Astra has in your future plans. So thank you so much for joining us this week.
Awesome. Thanks, Thomas. Thanks, Chris.
Yeah. To everyone who was tuned in, thank you so much for watching. Thank you for all the great questions and all the support. Again, I know we're not reading off super chats and stuff like that because we wanted to spend as much time asking as many questions as we could. But just thank you everyone who tunes in and gives us the support for us and Chris Kemp here. As far as this week's show, I think that's going to wrap it up. Chris Gebhardt, as always, thank you for joining the team. And then
My pleasure.
And then myself, Thomas Burghardt, writer and reporter for NASASpaceflight. On behalf of the entire NASASpaceflight team, a huge thank you to Chris Kemp for joining us again, and the best of luck on Astra and all of their future endeavors. So I think that's going to do it for this week's show. Stay tuned for more live launch coverage. We've got live coverage from Cape Canaveral coming up tonight, as well as all of the usual NASA Spaceflight content. But until next time, this is the NASA Spaceflight team and Astra CEO Chris Kemp signing off. Thank you so much for watching, and we'll see you next time.
Propulsion continues to be normal.
RCP chamber pressure looks good. Following up. Roger, roll, Atlantic.
Water towers can fly! Yes!
Tango Delta nominal.
Flight number SE off. Bring in SE off.
Yikes. You bet. Concur. We don't need any more of these.